All right, this is our last application for quadratics. This is a projectile being launched vertically in the air. So our question says a Dalek is launched vertically with an initial velocity of 49 meters per second from an initial height of 100 meters. So the quadratic function that represents this, with time being our t in seconds, and then s of t, this is our position, or height in this case, in meters. So you plug in some time t and it tells us the height of that Dalek. So if we plug in 2 seconds, and we plug that into our calculator, so this gives us 178.4, and then our height is in meters, so meters. So if it's launched at 49 meters per second from a height of 100, and then after 2 seconds, it would be 178.4 meters. And you can see this function, the speed goes here, that's your initial velocity, and that's the initial height. And this is gravity. Gravity is causing our speed to slow down. That's why it's negative. So now the next question is, what is the maximum height of our Dalek? So if you look at this, we are starting with a parabola, right? This is a quadratic. So our graph is a parabola, and since the leading coefficient is negative, we know our parabola is like this. It's going down, right? Let's get rid of those little arrows because we're doing more of a realistic. So it's this. This is our parabola. And if you want to find the maximum of the parabola, that's your vertex. So let's take a look at this with Desmos of what's going on with this function, and then we'll do the calculations by hand. So I'm going to hit play here. Let's turn off our parabola. And this is what's happening. So it's shot up with an initial velocity of 49 meters per second from a height of 100. It goes up, and then it comes down. You can see it's even speeding up as it gets closer, and then it hits the ground in 11.73 seconds. So here's the parabola that's matching it. So you can see it now. So the parabola maps the height of the function. So as time goes by, it's giving us the height of our object. And so that first one we had was 2 seconds. Doesn't like 2. Come on, there we go. So see, if I click on 2, it says 178.4. That's the height. That's where the parabola is. So if you have 2, it gives us 178.4. This parabola is our initial function that we were dealing with. And that's it. So if we want the maximum, the vertex is the maximum height. See how it goes up and then comes down? So our object starts at 100. See, we're at 100 here. And if I lower it, you can see that at the y-intercept here is just whatever number I pick. See, so that's 62. That's 62. So we're starting at 100. Right? With an initial velocity of 49, and then it goes up, hits a max height, which is the vertex, and then comes back down. So remember, if we click on this function, it tells us that's our max height. So at 5 seconds, moving it up, you can see right there, at 5 seconds, we get our max height. So our vertex of our parabola tells us the max height, and this is a good function, works perfectly fine, goes up, hits the max height, and then comes back down to the ground. And so you can see the parabola just tells us our heights. So we're starting at 100. See, we hit a max height of 2.5, and then after 11.739 seconds, it's back down to 0. So it's landing on the ground. So the parabola is giving us our heights as it moves through the function. Let's look at that one more time. So it goes up, starting at 100. Hits the max height, and then comes back down to 0. So there you go. See, those are the values that we're getting. And so you can see at any time, you get different values. Okay, so it's our vertex. That's it. And remember the vertex formula, x equals negative b over 2a. And we could just use technology like we did. We already knew that it was 5. And so x is not what we're looking for here, it's t. So our vertex here is t comma s of t in form. So if you take t equals negative b over 2a, we can then go back up and grab our b, which is negative 49. It's 49. So negative 49 over 2. And then our a is negative 4.9. And plugging that in our calculator, it gives us 5. So we know at 5 seconds, our Darlic will hit its maximum height. So how long will it take for the Darlic to reach its maximum height? 5 seconds. So now how do you find the max height? Well, you just plug it back in. So all we are doing is finding the vertex. So as if you plug in 49 and 5 into this formula, it tells us the height. So if we plug that in our calculator, we get 222.5. And then again with units, you just have to look back. We've already said time is seconds. So when you see t, you put seconds. Height is meters. So when you see the s, we put meters. And that matches perfectly with our projectile. See? Right there, that's our max height. And so you can see at 5 seconds, right there, that's the max height. See anything below or anything above, and the projectile is lower than the max height. So it's 5 seconds is when this projectile, our Darlic, will meet its highest point. So that's it. If they ask for the max height, you just use the vertex formula. So now when does the Darlic land on the ground? And so that would be a position of 0 meters. So we're looking for this situation right here. So it's what, comma, 0. How long does it take? We need some t value to make that. So what that is you take your function now, and we set it equal to 0. So if you look at that, that is just the quadratic formula. That's your a, that's your b, and that's your c. So we get x equals negative 49 plus or minus the square root of 49 squared minus 4, negative 4.9 times 100 all over 2 times negative 4.9. So the negative boy couldn't decide, go to the radical party with a square bouncer, remove 4 alcoholic cans, and it was all over at 2 a.m. So again, we start with that radical. And for these, we're looking for the exact value. And what we're doing here is looking back at the projectile to know which one to use for this application. Over here, we have 2 zeros. Say we have one here, and you have one here. So that's when our function equals 0. We want the positive one, because if you think about your parabola, it's always going to have this shape. And so we're not looking for the negative, we're looking for the plus. So you can even go back and just think about this. So if we have a negative and a negative and a negative, we want all the negatives so that we get a negative on the top, a negative on the bottom. And when you divide them, you get a positive. So we could just switch this right now to a minus if we wanted. But you're going to get 2 answers. And so we're going to do one with negative 49 plus this and one with negative 49 minus this. And what I'm going to do is the minus first. So if we plug the minus into our calculator, it will give us 11.739. And if we do the negative plus this radical all over it, it gives us the other one, which is negative 1.739. And since we have no time travel yet, at least in reverse, there is time travel forward, but not backwards. We know to eliminate this one right here and to keep this one. And so we still need time. I need to get rid of that x because it's not an x, it's a t. And we say t equals 11.739 seconds. So if this object is launched into the air at 49 meters per second, right, from a height of 100 meters, it's going to hit the ground at 11.739. It's pretty cool, right? Just from a formula. And now we can even do it with 300. So if we say negative 4.9 t squared plus 49 t plus 100 equals 300, then all you have to do is move that over, and we get 4.9 t squared plus 49 t, subtracting 300 from both sides gives us negative 200. That's it. So when will it be 300 high? And so now we just have a new formula. T equals, right, and it's negative 49 plus or minus the square root of 49 squared minus 4 times negative 4.9 times negative 200 all over 2 times negative 4.9. Now on this one, you do have to use both. So what does that look like? We can put over here a y equals 300. And what it does is it draws a graph for us. So when we solve this function, you're going to see that our projectile, can it hit that high? No, so we have to increase the velocity to get it up there, or you would have to increase the initial height. That would be the only way to get it above 300. So if we launch an object from 100 with initial velocity of 49, its max height is 222.5. It's not enough to get up there. So you could sit here and just play with the velocity. See, it's just a function until you get to 300. So we know we need something above what? Get it to be equal, above 62, 63, 64, somewhere in there. It's going to have more to get above there. So what that means is when you solve this quadratic, it's not going to give us real solutions. It's going to give us imaginary solutions. So let's see what happens to the inside. So if we take 49 squared and then put a minus, we simplify that radical, what we're ending up with is this. This is negative 49 plus or minus the square root of negative 1519 over negative 9.8. This is not real. It's imaginary, which that means is we're not going to hit it. Our 300 is too high. Too high. So what does that mean? It's not going to hit. So if you end up with a negative inside, it means that your Dalek or whatever your object that you're shooting up is not going to hit that value. If you get an actual number, then you will have that height. So if I had lowered this, if I lower this down, the actual height to here, you can see that there are two values that give us. So we will hit a height of 182. We'll hit a height of 182 at 2.125 seconds and 7.875 seconds. If I lower it more, we would hit a height of 130 at 0.655 seconds and at 9.35. So we're going to hit it going up and we're going to hit it going down. And you can even see that here. See, it goes up, hits it, goes to its max height, and then comes back down and hits it. So as long as it's lower than our max height of 225, our Dalek will hit it twice, except for anything below 100. If you're below 100, it's only going to hit it once on its way down because we're starting at 100. See? So we're already above it at 100. And so it will only hit it once on its way down. So that's it. These are projectiles. These are the questions you will get with projectiles. They will ask you things like find the height. And then also when will it hit some height? And you just use quadratic formula for the whens. And you plug it in to find the heights. And if you want to know what the maximum is, you use the vertex.